Welcome back. In this lesson, we will be creating our player and setting up his movement. We will do that by creating the player sprite, then importing his animation. Then we will be creating an object that uses that sprite. After that, we will dive into the code to change his x and y coordinates based on the keyboard inputs. So let's start by creating a sprite. Go ahead and right-click, create sprite, and we will name it as player work down. Now, included with this course files, you will find the downloadable zip file which contain the assets that we're going to be using for our course. Download that zip and extract it to your computer. Then click Import and navigate to your Assets folder and choose Player Workdown Step 4. And as you probably noticed, the image name ends with Step 4, which means once we import it, we will have an animation that's composed of 4 frames. So go ahead and click Open, and as you can see, our sprite have an animation that's composed of 4 frames. The next thing to do is create our player object. So head over to Objects, right-click, choose Create, then Object, and let's name our object O underscore player. And then let's add our sprite into it. Now that we have our player object ready, let's place it inside our home. So select our player object and place it inside our home. Now let's go ahead and click play to see how our game looks at the moment. And as you can see, our game looks fuzzy at the moment. So let's go ahead and fix that. So click the option button, this gear icon, then choose your operating system. I'm working on a Mac, but it's the same thing on Windows. So click your operating system and then click graphics and make sure to disable and interpolate colors between pixels. Then click apply, and if we click play at the moment, you'll notice that our game looks so much better. The next thing to do is creating our player movement. So let's head back to our player object and click add event, and we will add a step event, and you'll see this window asking if we're going to be using GameMaker code or GameMaker visual scripting. So go ahead and select GameMaker code and make sure to select Don't Ask Again for this project and then click OK. And the first thing we're doing is register the player input, which basically means we're going to detect what key the player is pressing on the keyboard. So we will start by deleting those comments and make a new one for our input. And we will start by having a variable called underscore right, which is going to be the keyboard check v key underscore right. So this variable will register if the player is clicking the right keyboard arrow. And as you can see, our variable starts with an underscore, and that's because it's a local variable, meaning we can only use it locally, so we cannot use it in another event or in another object. So let's do the same thing with the other keyboard buttons. So click Ctrl D if you're on a Windows or Command D if you're on a Mac. And let's make 4 variables for our 4 arrows buttons. So go ahead and name this left and change it to v key left down, and up. Now let's use this input to have our player movement. Let's make new comment for our movement, and we will simply add to our X position. So we will add our right variable minus our left variable. And to figure out the logic behind this line, let's think of the possible scenarios. So if the player is clicking the right button, we will have 1 on the right and 0 on the left. That's 1 minus 0, which equals 1. So our player will move by 1 pixel each step or frame. And if the player is clicking the left button, then we will have 0 minus 1, which equals minus 1. So our player will move by negative 1 pixel each frame, which means our player will move to the left. Now, if we click play to test that, you will see that our player can move right and left. And as a little challenge, I want you to figure out the vertical movement so that our player can move up and down. So pause the video and do that challenge and come back. Welcome back. I hope you figured that out. So what you have to do is copy this line and change it for our Y position. So for our Y position, we will have our down button minus our up button. And if we test that, we will notice that our player move right and left, up and down. So that's pretty much it for this video, and I will see you in the next one. Welcome back. In this lecture, we're focusing on making our player animations. So we'll start by creating different sprites, each corresponding to a specific animation. Then we will jump into the code to assign those animations based on our player object movement direction. After that, we will make the animations stop playing if the player is not moving. And finally, we will make our player move faster to match our animation speed by creating a variable that controls our player speed. So let's start by creating our sprite. We will make a new sprite and name it S underscore player walk up. And let's import the corresponding animation. And let's do the same thing for the right and left animation. Now let's head over to our player object, and in the step event, let's add new comment to specify that this is going to be our animations code. And let's create an if statement. We will be testing if the right keyboard button is pressed. So if underscore right. So if we're pressing the right button, we will change our animation to S player walk right sprite. So sprite index, and this is a built-in function that's responsible of assigning sprite to our object, and we will assign to it our s underscore player work height. So if we're clicking the height button, we want our player to have the s underscore player work height sprite. And as you can see, if I hit play, if I move to the right, our player changes its animation to S player work height. Now let's do the same thing for the other animations. So select this code and Ctrl D, Ctrl D and Ctrl D 4 times. And if I click the left button, I want my sprite to be S player work left, and the same thing for up and down. Let's test that one more time. And as you can see, our player changed its animation based on our direction. The only problem is that if we are not pressing any keyboard button and we are not moving at all, our player keeps animating. So let's change that. And to do that, we will use another GameMaker built-in function that's called image speed. And this is simply the speed of our animation. So if we're not pressing any button, we want our speed animation to be 0. And if we're pressing the right button, we want our image speed to be 1. Same thing for the left. Up and the down button. So if we're not pressing any button, we want our animation to be 0, meaning we want to stop our animation. But if we are pressing any button, we want our animation to move in its normal speed. So let's go ahead and test that. And as you can see, if we're not pressing any button, our animation is 0, meaning our animation is frozen. And if we are moving, as you can see, we'll get our animation speed back to its normal state. And now our player is too slow at the moment, and also it's not matching the speed of our animation. So let's change that. And we will start by adding an event, and that's going to be the create event, and we will have a variable named movement speed. And I'm going to give it a value of 1.5, but you can use a different number. You can use a bigger number if you want your player to be faster, or a smaller number if you want it to be slower. And we will use this variable to control our movement. So we will multiply our movement by our movement speed before adding it to the X position. And we will do the same thing for our Y position. Now let's see how does that look. And as you can see, our player move faster now and match the speed of our animation. So that's pretty much it for this lecture, and I will see you in the next one. Welcome back. In this video, we will be making our player attack, and we will do that by first importing our attack sprites. Then we will head over to the code and we will make a direction and a state variable that will determine if we're moving or attacking. After that, we will start working on our attacking logic, where we will determine which attacking animation will be played based on our direction. And lastly, we will use a new event called animation and to get back to our working animation once our attack is finished. And let's start by creating our attack sprites. And I'm going to name this sprite S underscore player attack down. Click import and choose player attack down step 4. Let's do the same thing for the 3 other sprites. And let's head over to our player object. And in the create event, let's add 2 variables. The first one is player direction, and let's set that to be down at the start of the game. And the second variable is state, and this will be our player state, meaning if he's walking or attacking or doing something else. And let's set it to be idle at the beginning of the game. Now let's head back to our step event. And in our movement code, since we will work with states, let's make sure that our player moves only when he's at the idle state. So if state equals idle, then we will move and collide. Same thing in our animation. If state equals idle, then we will do the animation logic. And if you like, you can click Tab to make the code move to the right. Also, let's set our player direction. So, if we move to the right, our player direction will be right. If we move to the left, our player direction will be left. Same with the up, player direction will be up. And same thing for the down, player direction down. Now, let's start working on our attack. First, in our input, let's add an attack button. So, Ctrl D, var attack, keyboard check released. Since we want our attack to happen on button release, not on hold, and I'm gonna choose the space button. But you can choose any button you like. And now let's start working on our attack code. Let's make a comment to specify that this is gonna be our attack code. And the first thing to do is we will check if we click the attack button. If underscore attack, we will set our image index to 0 so that our attack animation always start at the beginning. and then we will change our state to the attack state. So state equals attack. And now we can check if we are in the state attack. So if state equals attack, and if we are, we will do a switch condition. And this is basically the same as doing a bunch of if statements. So instead of doing if player direction is down, do this, if player direction is up, do this, etc., etc., we will do switch player direction. Case down. So if our player direction is down, we will change our sprite. So sprite index equals s underscore player attack down. And we want our image speed to be 1, and then break to get out of the switch statement, and Ctrl D 3 times, and let's do the same thing for all directions. So up, our index will be player attack up, same with right, player attack right, and same with left. And if we test our game right now, you can see that once our player starts attacking, he will get stuck in that animation. So let's fix that. And to do so, we will have to create new event. So add event, other, animation end. And this event will get executed every time our player finishes one of his animations. And in here, we will check if we are in the attack state. So if state equals attack, and we will do switch statement. So based on our player direction, case down. So once our down attacking animation ended, we want our sprite index to get back to player walk down. So sprite index equals s underscore player walk down, and then break, and Ctrl D 3 times, and we will do the same thing for the other directions. So up is s underscore player walk up, height is s underscore player walk height, and left is player underscore walk left. And also we will set our state back to idle. Let's test our game again. And as you can see right now, our player finishes his attack and then get back to the idle state. So that's it for this video, and I will see you in the next one. Welcome back. In this video, we will create our player hitbox, and we will do that by first creating an object for it. And in his create event, we will define our hitbox size. After that, and in our player object, once we're in the attack state, we will spawn our hitbox and set his size based on our direction. Then we will draw it into our game. So let's get started. And we will start by creating an object. and I will name it O underscore hitbox. Then in his create event, so let's add an event, create. We will create 4 variables corresponding to our hitbox edges or sides, and we will initiate them at 0. So top equals 0, bottom also equals 0, height equals 0, left equals 0, and now we will return to our player object, and in his step event, and if we are in the attacking state, let's create new variable for our hitbox. So var hitbox, and we're gonna instantiate our hitbox and assign it to this variable, and we will do so by using a predefined function called instance create layer. And this function creates or spawn new instance of an object at a specific position, and it takes 3 arguments. First is the X position we want our object to be created at, and that's our player X, so X, then the Y position, then the layer at which we want our object to be. And if we head back into our room, you can see that all our objects are in the instance layer. So we will use that. And the last argument is the object we want to spawn, and that's O hitbox. Now let's set our hitbox sides based on our player direction. So if player direction is down, and if we go quickly to our room, now if we're facing down, we want our hitbox to be here. So the top side of our hitbox should be here, the right side here, the bottom side is here, and the left side should be here. So for our hitbox left, it's going to be our X minus 10 pixels. And for our hitbox top, it's going to be our Y plus 20 pixels. And for our right side, it's going to be our X plus 10 pixels. And for our bottom, it's going to be Y plus 10 pixels. Now, I've came up with those numbers by trying different values, but you can use other values if you like your hitbox to be different. Now, since our hitbox object is empty and doesn't have sprites, if we test our game, we will not be able to see it. To fix that, let's head back to our hitbox object and let's add a draw event. So add event and choose draw. And this is basically an event we use when we want to draw something to the screen. And here we will use a predefined function called draw rectangle, because our hitbox is technically a rectangle, not a box. And this function takes 5 parameters. The first four are our rectangle four sides, and the last one is to indicate whether to draw only the outline of the rectangle or fill it completely. So in our case, our sides are left, top, right, and bottom in that order. And we only want the rectangle outlines, so the fifth argument should be true. And you can try to put false instead if you like. Now let's test our game. And as you can see, if I face down and hit the attack button, I can see my hitbox. Now let's head back to our player step event. And let's set the other direction's hitbox edges. So Ctrl D, and for our up direction, our hitbox left side will be x minus 10, and our top side will be y minus 20. Our right side will be x plus 10, and our bottom side will be y minus 10. Ctrl D again. And for our right direction, our left side will be x plus 8. Our top side will be y plus 4. Our right side will be x minus 24. And our bottom side will be y minus 4. Ctrl D again. And for our left direction, our left side will be x minus 8. Our top side will be y plus 4. Our right side will be x minus 24. And our bottom side will be y minus 4. And I made a little mistake here. For our right direction, our right side, it should be x plus 24, not minus 24. And you can play with different numbers and make your hitbox different than mine. So let's test and see how does this look. And as you noticed, we can see our hitbox and it's based on our player direction. So that's it for this video, and I will see you in the next one. Welcome back. As you can see right now, our hitbox gets spawned and stay active as long as the game is open. Also, if we hit our enemy, nothing happens. So in this video, we're going to fix those problems, and we will do that by first creating an alarm that destroys our hitbox after a certain time amount. And then we will detect if our hitbox collided with our enemy. If so, then we will destroy our enemy. So let's do that. We'll go to our hitbox object and then add event, then alarm, and we will choose alarm 0. And this is simply a timer that counts down from a given value to 0. Now in the create event, let's trigger our alarm. And we will do that by writing alarm 0, which is the name of our alarm, and then 20. And this is the number of frames before our alarm gets called or executed. So after 20 frames, any code that's in our alarm event will get executed. And after 20 frames, we want our hitbox to get destroyed. So we want this object to get destroyed. And to do that, we have this predefined function called instance destroy. So if we test our game right now, you can see that our hitbox stays for 20 frames, and then get destroyed. The next thing to do is to make our hitbox destroys our enemy if it collides with it. And to do so, let's add a step event to our hitbox. And in here, we will create a new variable that will verify if we collided with our enemy. So var collision enemy, and we will use a function called collision rectangle, and this function will check if the rectangle that's composed by the first 4 arguments has collided with the object that's given as the 5th argument. So in our case, our rectangle sides are left, top, right, bottom, in that order. And the object we want to check if our rectangle has collided with is O underscore enemy. And the next argument should determine if our collision is very precise, and we don't want that. So we're gonna type false, and we want this object to be included in this function. So for the last parameter, which is also known as the not me parameter, we will also put false. Now if our variable, the collision enemy, has any value inside of it, meaning if it's not empty, then we will destroy that variable using the instance destroy function. Except this time, we will pass the object we want to destroy as an argument, and that's collision enemy. Now, one last thing before testing our game is to delete the though event, since we only used it for testing, and we don't want to see our hitbox in our game. So let's hit play. And now you can see that if we hit our enemy, or rather if our hitbox hits our enemy, then our enemy will get destroyed. And that's it for this video, and I will see you in the next one.